Well, this video is for Math 111 for Section 2.6 on polynomial long division. So first I'll go over the process for doing polynomial long division. Then I'll talk a little bit about what that does, why the process works the way that it does, and then we'll look at a couple example problems. So for starters, I'm going to do the problem on page 115 here. We've got a polynomial 2x to the fourth plus 7x cubed plus 4x squared minus 2x minus 1. And that's getting divided by x squared plus 3x plus 1. Okay, so first, like I said, I'll talk about how we go about doing polynomial long division. It works a lot the same way that numerical long division does. And so we look at the highest power of the x in what we're dividing by, and we look at the highest power of x in what we're dividing into, and we ask, what do we need to multiply this by to get this answer right here? Well, this is a 1x squared, this is a 2x to the fourth, so we're going to need a 2, because 2 times 1 will give us the 2. And then we're going to need an x squared, because the x squared times the x squared will be x to the fourth. Alright, so now we multiply 2x to the fourth, and we have to distribute. We have to multiply this 2x squared times all 3 of the terms that we're dividing by. So let's see, this will be 6x to the third, and then plus 2x squared. And then we subtract, or change the signs, because if these were negatives, they would change to positives. So we're going to subtract by changing the signs. These cancel each other out. Here we get 1x cubed, and then plus 2x squared, and then we'll bring down the minus 2x. And then we just do the same. We just repeat this process over, okay? What do we need to multiply the x squared by to get x cubed? We're just going to need 1, and then x to the first, and so that'll give us 1x to the third, and then 3x squared, and then x. Alright, and then again, we'll change the signs. These cancel out. Over here, we end up with negative 1x squared minus 3x, and then we bring down that minus 1. Now, what do we multiply 1x squared by to get negative 1x squared? Negative 1. And if we do that, what we'll notice is that these all match up, all of the terms match up, so that when we go in and change the signs, remember how I said we're subtracting by changing the sign, so that if these were negative, they would change to positive. So that's what we're seeing down here. All right, these all cancel out, and we get a remainder of 0. So this divides in evenly. This polynomial divides evenly into this polynomial, and the answer is right here, 2x squared plus 1x minus 1. Okay, so that's the process, and we'll come back to this in a few minutes when I go over some sample problems. But let's talk about what is this process doing? Why do we do this the way that we do? And the whole idea is, let's see, let's look at a simple numerical example. If we want to do, let's say, 50 divided by 7, let's pick something better here. Let's do 60 divided by 7. 60 divided by 7. So this will go in 8 times. 8 times 7 is 56. We subtract, and we get a remainder of 4. And so what this tells us is that 60 is equal to 7 times 8 plus 4. So the key here in performing long division is finding this number and this number, okay? We want to know, what do we need to multiply 7 by to get close to 60, and what's the remainder going to be? Okay, now let's translate that to the polynomial problem that we were just looking at. Okay, so in this problem, we're saying, let's see, I'll write it down and then maybe let's see, if I've got room here. 2x to the fourth plus 7x cubed plus 4x squared minus 2x minus 1. So what we're saying is that this has to be equal to x cubed plus 3x plus 1 times something plus our remainder. Okay? And this will be the quotient right here. Okay? So in our numerical example, the quotient was 8, the remainder was 4. Now remember, in this problem we just did the long division. Our remainder is going to turn out to be 0 here, but we don't really know that ahead of time. Okay, so that's what we're looking to find, is we're looking to fill in these blanks right here. And the way that we do that is very similar to what we were doing in the long division problem. Well, we're going to have to distribute this. Is that x to the third power? That is x squared. Okay, I wrote it down wrong. That would really have thrown things off. There we go. Okay, so it's the same question we asked when we were doing the long division. If we're going to distribute this into this parentheses, then what we multiplied here better give us a 2x to the fourth. Okay, so to set that up correctly, this would have to be 2x squared. Okay. But here's the thing about multiplying polynomials. You don't just multiply these two pieces. You also have to distribute this 2x squared to the other terms in this polynomial right here. Okay, so that's going to give us a 2x to the fourth, good, but it's also going to give us a 6x to the third and a 2x squared. Okay, next we need to ask, how do we get the next highest power of x, the 7x to the thirds? Well, that would come from multiplying this x squared times an x to the first power. Okay, because that's how we would get the x to the third. But notice how we've already got 6x to the third, so we don't need 7 of them anymore. We only need 1 of them. That's what that subtracting in the long division process does, is that answers our question. Oh, we've already got 6 of them. We need 7. That means we only need 1. So that's why we say 1x here. That'll give us another x to the third. Then it'll also give us a 3x squared and a 1x. Okay? So now we've got our 2x to the fourths. We've got our 7x cubes. We've got 5x squareds, but we only needed 4. Well, that means that we better take 1 away. Okay? So that means the next thing that we're going to multiply by here is going to be minus 1. So that when we multiply by this x squared, we get minus 1x squared. We're also going to get minus 3x and minus 1 out of that. Okay, so now we've got our 2x to the fourths. We've got our 7x cubes. This is going to give us 4x squareds. And notice this is why we ended up with a 0 remainder, is because this gives us just what we need. Minus 2x and minus 1. It all matches up. Our remainder is 0. And this all adds up to what we were dividing into in the first place. Okay, so I don't know if that helps you to understand the process of long division a little bit better. I hope that it does. But if you ever question, what am I doing as I go through this process, this is what that process is doing. Okay, except that the idea is that it's a little bit simpler in that long division form. Okay, let's look at some sample problems in the exercises. On page 119. So, problem 2, we have x to the third minus 5x squared plus x plus 15. And this is going to get divided by x minus 3. Okay, so again, the process is go to the highest power of x in what you're dividing by, look at the highest power of x in what you're dividing into, and what do you need to multiply this by to get this? And here the answer is 1x squared. And then multiply. That'll be x to the third minus 3x squared. And then we subtract, which means change the signs. Okay? And this is the process where we find out how much more will we need. Okay? In that explanation I was giving a few minutes ago there. Okay, these cancel out. That's what we wanted. Here, negative 5 and positive 3 makes negative 2x squared. Then we'll bring down this plus 1x. Okay, so this is telling us we need negative 5x squareds. We're going to have negative 3 of them. That means we need minus 2 more of them. Okay, that means that x into negative 2x squared, we're going to need to multiply by negative 2x to the first. And that'll give us our negative 2x squareds. And then we also have to multiply by that negative 3. That'll give us positive 6x. And now we've got to go in and change the signs. These cancel out. Here we get negative 5x. And then bring down the positive 15. What do you multiply x by to get negative 5x? Negative 5. And then multiply by the negative 3. Notice how they match up exactly, so that when we change the signs, we get a 0 remainder. And there's our answer right there. All right, so that's problem 2. Let's see here. Let's look at problem 4. Here we've got 2x to the third minus 3x squared plus 7x minus 3. And that's getting divided by x squared minus x plus 3. Okay, same process. What do you multiply the x squared by to get 2x to the third? The answer is 2x. All right. And then we'll multiply and then distribute to also the minus x, so that'll be minus 2x squared, and distribute to the 3, positive 6x. Then change all the signs, minus, plus, minus. These cancel out, that's how we got started. Over here, negative 3 and positive 2 makes negative 1x squared, positive 7 minus 6, positive 1x, and we'll bring down the 3. Now, what do you multiply x squared by to get negative 1x squared? Negative 1. Distribute here, that'll be positive, and there will be negative. And again, they match up so that when we change the signs, we come out with a 0 remainder, and there's our answer. Okay, a lot of these I've set up to have 0 remainders because in the Section 2.8, where we're going to be using this with graphing, we're going to be working mostly, actually exclusively, with problems where you get a 0 remainder. Okay, I'll talk more about that when we get to that section, but that's what we're going to be using this for. Now let's look at what happens if we do a problem where we get a remainder that's not 0. Okay, so problem 6. We're dividing x to the 4th plus x to the 3rd plus 5x squared plus 3x plus 6. And that's getting divided by x squared plus x minus 1. Okay, so what do we multiply the x squared by to get x to the 4th? 1x squared. And then distribute. And distribute, and then we'll go in and change the signs, negative, negative, positive. So this cancels out also, okay? And then over here, positive 5 and positive 1 makes 6x squared, and we'll bring down the 3x as well, okay? And actually, since we've got 3 terms here, let's bring down this 6 along with it. Because now when we ask what do we multiply the x squared by to get 6x squared, the answer is just 6. So there's 6x squared, and then plus 6x minus 6. Now when we go in and change the signs, what we notice is that we don't get a nice 0 remainder. And that's fine. A lot of problems you're not going to get a 0 remainder. Now these cancel out. But here we get 3 minus 6 is negative 3x, positive 6 and positive 6 make positive 12. So that's our remainder, is negative 3x plus 12. Okay, and there's nothing wrong with that. Like I said, a lot of problems will have remainders. Some problems will have this nice zero remainder. But what we're going to be using this for in section 2.8, we will always end up with a zero remainder. Okay, let's look at problem 10. Let's see here. So, in problem 10, we have 2x to the 4th plus 3x to the 3rd plus 3x squared minus 5x minus 3. And this is going to get divided by, let's see, what is this going to be divided by? 2x squared minus x minus 1. All right, so same process. What do you multiply the 2x squared by to get 2x to the 4th? Well, we don't need to multiply the 2 by anything, but we do need an x squared to raise this power from 2 to 4. So that'll give us 2x to the 4th, and then minus x to the 3rd minus x squared. And then we go in and change the signs. So these cancel out. Here we get 4x cubed, and here we get 4x squared. And since we've got 3 terms here, let's bring down this minus 5x. All right, so what do we multiply the 2x squared by to get 4x to the 3rd? That'll be just 2x. So there's 4x to the 3rd minus 2x squared minus 2x. Okay, go in and change the signs. Let's see, that'll make 6x squared. And then minus 3x minus 3. And so what do we multiply by here? Positive 3. So that'll be 6x squared minus 3x minus 3. And then you can see that they're matching up exactly again, so that when we go in and change the signs, we get a zero remainder. Okay. So that's how we do polynomial long division. I think we can stop there. Well, let me look at one more. Let's look at problem 14, because there's something in problem 14 that we haven't seen before. So let's go ahead and take a look at that. So problem 14, we start out with 3y to the 3rd minus 4y squared minus 3. So notice that there's a power of y missing. We're missing the y to the first power. And that's fine, but we just have to be careful when we're doing the long division. And we're going to divide by y squared plus 5y plus 2. All right, so what do we multiply the y squared by to get 3y to the 3rd? Well, we need to multiply by 3 and y to the first. All right, so there's our 3y to the 3rd, and then 15y squared, and then 6y. Okay, so then we go in and change the signs. These all switch to negatives. These cancel out, great. Negative 4y squared, negative 15y squared, that's minus 19y squared. Here we don't have any y to the firsts, so it's just 0 minus 6y is negative 6y, and then we'll bring that 3 down there. Okay? All right, then we're going to need to multiply by negative 19. So that'll give us negative 19y squared. And wow, let's see here. That's going to be negative 95y. Okay. And then minus 38. All right, then we go in and change the signs. These cancel out. That's what we wanted. Here we get 95 minus 6, so that's going to be positive 89y. And over here we're going to get positive 35. So in numerical long division, you know you can stop when your remainder is smaller than what you're dividing by. In polynomial long division, you have to stop when the power of your variable in the remainder is smaller than the power of the variable you're dividing by. So this is our remainder right here, 89y plus 35. Okay, all right, so that's it for section 2.6. We're going to move on to 2.7 and look at synthetic division, and then in section 2.8 we're going to use this to break polynomials up into factors. As always, if you have any questions, please let me know. Thanks.